All right, getting ready for that SPM chemistry paper? Well, you've come to the right place. Today, we are going to crack one of the most important topics out there, thermochemistry. And I promise, we're going to make it super simple, clear, and totally unforgettable.
Yeah, that feeling. We all know it, right? The exam date is just staring at you from the calendar, and the pressure is definitely on. It can feel like a lot, but here's the secret. You just gotta focus on those high-impact topics and really, really get them. So you know what? Let's turn all that pressure into some solid preparation. In this little explainer, we are going to break thermochemistry down into bite-sized pieces so you can walk into that exam hall feeling like you own the place. Okay, but before we jump in, here is my #1 pro tip. The best way to make all of this stuff stick is to practice. So after we're done here, go ahead and scan this QR code or just visit www.mcqspm.com. It is absolutely packed with past year questions, which means you can take what you learned today and use it right away. Oh, and you can find the MCQ SPM app on the Google Play Store too. Super handy.
Okay, let's get right to the heart of it. The word thermochemistry sounds kind of complicated, right? But honestly, it all just boils down to one simple idea. A chemical reaction is either going to release heat or it's going to absorb it. That's it.
And this image, it just captures the whole thing perfectly. It's like two sides of the same coin. You've got the blue, cold side, that's heat getting absorbed, and then you have the red, hot side, that's heat getting released. Really, when you think about it, thermochemistry is just the story of heat moving in or moving out. And of course, these two sides have names you've probably heard a million times: endothermic and exothermic. So, an endothermic reaction, it pulls heat in from its surroundings. That's why the beaker would feel cold to the touch. And an exothermic reaction does the opposite. It pushes heat out, making everything around it feel hot. See? Simple as that.
All right, let's zoom in on endothermic reactions for a sec. I've got a great little memory trick for you. Think of the En in endothermic as energy entering the system. Get it? It's like a little sponge, just soaking up all the heat from the air around it. Now, here's the super common mistake I see students make all the time. They forget that it's the surroundings that get colder. The reaction is gaining energy, but the beaker, the air, that's what feels cold. And now for the flip side, we've got exothermic reactions. And you guessed it, think of the X as energy exiting the system. This reaction is basically throwing off heat. It's like a tiny bonfire in a beaker, warming up everything around it.
Okay, now let's get a little strategic here because, look, knowing the concepts is only half the battle, right? The other half is knowing how they're going to ask the questions on the exam. So let's look at a reoccurring favorite, one of the examiner's pets. And believe me on this one, SPM examiners have certain concepts they just love to test over and over and over again. And once you learn to spot these patterns, well, you can practically guarantee yourself some easy marks. And this next one, it's a classic.
Just look at this data from past papers. I mean, seriously, look at it. 2011, they ask about cold packs. The answer is ammonium nitrate. 2015, same question, same answer. 2019, you guessed it, same again. And just last year, 2023, yep. This is not a coincidence, people. This is a classic exam pattern, and you absolutely have to know it.
So, when you're sitting in that exam hall and you see a question that looks anything like this, a light bulb should go off in your head. Ding! You should immediately recognize it for what it is. It's a direct test to see if you can connect the idea of cold to a specific endothermic reaction. And here is why the answer is always ammonium nitrate. When you dissolve it in water, it kicks off this super powerful endothermic reaction. I mean, it just sucks up a ton of heat energy right out of the water, making the temperature of the pack just plummet. So here's the magic formula you need to remember. Cold pack equals endothermic equals ammonium nitrate. Burn that into your brain. But hey, this stuff isn't just about passing your exams. Honestly, once you start looking for it, you'll see thermochemistry is happening all around you, every single day. I mean, think about it. Ever seen one of those self-heating coffee cans? That's an exothermic reaction releasing heat. Cooking with a gas stove? Pure exothermic combustion. And on the flip side, what about those fancy self-cooling beverage cans? That's endothermic. Even something as simple as eating sorbet, the reason it feels so cold is because it's literally absorbing heat from your tongue as it melts. That's an endothermic process right in your mouth. All right, let's switch gears a bit. We've talked concepts, now let's talk calculations. This is another area where, I'm not gonna lie, a lot of students lose marks. But the math is actually super straightforward once you know the steps.
It's all about figuring out which fuel gives you the most bang for your buck energy-wise. And the key term you gotta know here is fuel value. It's basically a measure of efficiency. It tells you exactly how much heat energy you can get from burning just 1 gram of a fuel. So, pretty simple. The higher the fuel value, the more energy is packed into that fuel. Okay, let's walk through how to calculate this using octane, a component of petrol, as our example. It's just a few simple steps. First, you find the molar mass. That's just basic calculation, comes out to 114 grams per mole. Second, you'll be given the heat of combustion, which here is 5,500 kilojoules per mole. Third, you just plug it into the formula, which is simply the heat of combustion divided by the molar mass. So you take 5,500 divided by 114, and you get your answer, 48.2 kilojoules per gram. See? It's really that straightforward. And this is why that calculation is so important. This bar chart tells the whole story. Look at petrol over on the left. Its fuel value is around 34. Okay. Natural gas, it's a bit better, sitting at 50. But then, just look at hydrogen. Its bar is just towering over the others at a whopping 143 kilojoules per gram. This shows you, clear as day, that gram for gram, there's just no competition. Hydrogen is a way, way more powerful fuel. All right, we have covered a lot of ground here. So as we start to wrap this up, let's just boil everything down to the absolute must-know, can't-forget essentials that you need to carry with you into that exam. Okay, listen up, because here are the 4 key takeaways. If you remember nothing else from this, remember these. Number 1, endothermic reactions absorb heat and get cold. Number 2, exothermic reactions release heat and get hot. Number 3, that classic cold pack question, the answer is ammonium nitrate, always. And number 4, a higher fuel value just means you're getting more energy per gram. That's it. Those are the golden rules. And I'm going to leave you with one final question to chew on. We just saw pretty dramatically that hydrogen is an incredibly powerful fuel, right? So why are we all still driving around in cars that run on petrol? The answer goes way beyond just thermochemistry. It gets into things like cost, how you store it, how you get it to people, and it really proves that in the real world, chemistry is just one piece of a much, much bigger puzzle. Something to think about, isn't it? All right, good luck with your studies.